Hello, welcome to my TED Talk regarding well-designed solutions. Solutions that both solve a problem and explain how and what they're doing. So, being able to read your own code is an essential skill, and whether it's a week, a month, or a year after you wrote it, you should be able to read and understand it. And the first step to writing any code is understanding what it is that you need to solve. So read the whole problem, usually multiple times, and go through and formulate a rough plan on what the order you're going to implement everything is. And usually you do this by difficulty. You find the most difficult sections and you say, okay, we'll do those later, and you really focus on the easier sections. And basically, once you can describe your problem to someone else, then you're ready to solve it. And if you ever get stuck at any part, you should take a step back, explain what it is that you're doing clearly in English, and then move forward and proceed to solve it. Now, there's two major approaches to solving problems. There's bottom up and there's top down. They both have flaws and advantages. So one of the major flaws of top down is that you create a solution that is so specific to the problem that it can't be adapted to work with other things. One of the flaws of bottom up is that you write code that you don't know if you're going to use, and you end up with a lot of unused stuff. And the major advantages of each are bottom up offers a lot of portability, so it is not redundant by definition. And top down guarantees that every bit of code that you write will be used and all of your pieces will fit together smoothly. So you want to use a mix of both of them. You want to use top down to break the problem into challenging chunks, and you want to use bottom up to build the chunks. And if your chunks are trivial, you've used too much bottom up. And if your chunks don't fit together at all, then you've used too much bottom up. So you need to find the right mix depending on your problem. Now, before you begin, you'll want to generate a set of inputs that you're going to plug in when your code is up and running. And meaningful inputs basically mean that if your code does one thing for odd numbers and another thing for even numbers, if all you test are even numbers, half your code is susceptible to error. So you can test an infinite number of things without really accomplishing anything. So however many paths there are that your inputs can take to produce an output, generate enough inputs to test every possible path. Now, I always like to start with my print and debugging components of my code so that I can always check certain variables at certain points. And I always like to start with the least difficult stuff and then build my way up to the more difficult stuff, because usually the more difficult stuff involves combining the least difficult pieces. So when you combine your pieces, you should combine no more than 5 at a time, because if something goes wrong, trying to look through more than 5 pieces and pinpoint where the error occurred is near impossible. And this is the stage where you find that some of the decisions you made early on might not have been the best decision, so you might want to change some stuff. And whenever you go to change something, you really have to ask yourself, what is the scope of the change I'm about to make? And then you have to quantify the benefits of the change. So you should go through and you should look at everything that you're going to change, and you should say, does it have a positive impact, a neutral impact, or a negative impact? And if the result is overwhelmingly positive, you should definitely, without a doubt, change it regardless of how many places you have to go through and tweak. But if the average result is neutral, then you have to put a little more thought into whether or not the change is really the right step. And whenever you walk away from your code, and you give it the seal of approval, you should ask yourself, if I look at this same code 3 months later, will I be able to read it and understand it? And unless your answer is yes, then you should spend a little more time on it and maybe go through and add some notes. And really, good code is like a story, so you should be able to read it even if you don't have the problem that it solves right next to you. Thank you.